Hi, it's Matt from Krank Engineering, and today I want to do a video about one of the jobs that I've got in the shop and just talk about the process that I use to help this particular customer out. So this steering stem and lower triple, I'm not sure exactly which bike it's out of, but the customer is transplanting a front end from one bike into another. And for the frame that he's using, he wants this steering stem shortened by 31 millimeters. So it's got to go down something like down there into the threaded section. It's got to be cut off. So for that obviously to work, we need to rethread that steering stem so that you can screw the nut down on the top. So to solve this particular problem for this guy, we need to shorten it and rethread it a little bit further down. So there's a couple of ways you can go about this, and let's talk about how I might do it on this particular bike. So this particular stem is a steel stem. I haven't seen one that's not steel. In this particular case, it's welded into the lower triple clamp. So it's a steel, I'd say it's cast steel. I don't know for sure, but I'm guessing that if it's already welded in, you've got to weld it to compatible materials. So it's a steel stem, and I'm guessing it's a cast steel lower triple. So you could, grind this weld away, remove the stem and chop it off a little shorter, put it back in and then re-weld it. That'd be one way of doing it. And I have discussed that with the customer, and he's raised a couple of valid points before I saw this particular stem, and that's the different steps in it. So here's the lower bearing race, which sits right down the bottom here. This particular stem, it may be difficult to see in the video, but this particular stem, it measures 24 right down the bottom, and as you come up a little bit further to the center, it measures 23, and then it measures 22 here, and then the thread is 22, and I've actually used a thread gauge and a verniers and everything, and this is a 20, what did I say it was, a 22 M22 by 1 thread, which is a really fine thread. So because of the steps in here, obviously you want to reuse the same bearing race. If I grind the weld off and cut this and shorten it, then there's this bearing race is going to be sitting on this section of the stem, and it's loose, it doesn't fit. Down here it's a press fit, so because the shaft is stepped from here and it steps down, the bearing wouldn't sit properly on the stem. So the more appropriate solution in this case is to take 31 millimeters off this end and then rethread this part of the stem. So to do that, easy to chop it off, but then we've got to rethread. So to do that, I need to turn this section of the steering stem down to the right diameter to match this, and then use a die and recut the thread. And I think after I've done that, then I will set it up and I'll cut it off at that point. So, and the reason I'll do that is the existing thread will give me something to start the die on, so I can wind the die down on the existing thread and then keep going and then cut the thread for the new section a bit further down. If I cut this off first, so I don't have as much to get a start on, with quite a large thread and a very fine pitch, it'll help to have the die started on this section of thread. So that's I think the process that I'm going to follow. So this particular stem, hopefully it's visible in the video, it is hollow, so I can chuck this in the lathe between centers, and I can use that to hold it while I turn this section of shaft down. And after I've done that, I can rethread it. Now I've had to order a die for this. I don't have one in that particular size in my collection. It's an unusual thread pitch, not a very common one. So I'm taking a punt. I've ordered a really cheap die off eBay, straight out of China. I'm only going to use it once. I may never use it again. So I'm not going to spend $100 on a really high quality die for a one-off job. In this particular case, I am taking a gamble. I'm going to order a cheap one from China. But because I am starting on this existing thread, I think the risk's pretty low that it's going to cause any problems. So yeah, the process will be chuck it up, turn this section of the stem down to the correct size for this thread, and we can look that up in some tables. Wait for the die to turn up from China, so it's on the way. Then I can thread this, thread the rest of the stem, chop it off, clean up the front here, the top of the thread, put a chamfer on it like this, and away we go. So I'll move the camera around and show you what these steps in the process as we're going. I probably should talk quickly about how I determine what this thread is here. Now I don't know exactly which bike this particular stem came out of, but as a general rule I normally assume that if it's out of an American bike like a Harley, it'll be in imperial measurements, so inches of some description, and if it's Japanese or European, it'll generally be metric in millimeters. So I did get a heads up from the customer. I think it's an Asian bike of some description, so I'm going to take a punt and assume it's metric. And just to confirm my my guess, I did start taking some measurements here, and you know, this is just about 24. It's a shade over 24 millimeters. Here's a shade over 23, and here's, where we are, 22 and a half or so. Then down on the thread we're about 22. You know, you do have to take a bit of a guess. If you converted some of those to imperial and took a measurement here, you know, 0.94995 is not really a standard dimension for a bearing. So I'm going to say it's a metric steering stem. So I take a rough measurement across here, and we end up with not much good in inches. So we convert that back to millimeters. So we're around about 22 millimeters. So I'm looking for a metric thread that you know, the major diameter is 22 millimeters. So the next step is I've got to work out what the pitch of this thread is, and generally to do that you're using thread gauges, and this is a combination set. So on one side here it says V, US, American, and NAT, national, and on the other side it says metric, 60 degrees. So it'll measure thread pitches in metric threads and also imperial threads. So this is a sort of a one tool does all. These aren't cheap, these little guys. These are probably $50 for one of these, but you know, when you really need one, you need one. So to determine this, I'm not going to use the American or the national ones. I'm going to go to the other side and use the metric. And these little leaves, I guess you call them, they're all got different thread pitches on them. So hopefully they come up all right in the video. So this first one here, it's stamped with the number 5. So that's, 6 millimeters. So 6 millimeters crest to crest, 5, 5.5, and so on. They get smaller and smaller and smaller and smaller, and this particular one finishes at 1.25, and then you flip it over to the other side and it starts at 1, 0.9, 0.8, so on. So what you've got to do is match up one of these to the thread pitch that you're looking at, or that's got it under investigation. So having done this before, I know it's 1 millimeter, right? So the 1 millimeter thread gauge fits there very nicely. Normally you'd hold that up to the light and check how good the fit is. I won't do that here because you won't be able to see on the video anyway. So 22 millimeters, 1 millimeter pitch, and next thing I get out one of my handbooks and I have a look, metric or isometric threads, diameter and pitch combinations. And I go down the table and I look for M22, so metric 22. It's not a coarse thread, so 16, 20, 24. Metric fine, so M22 by 2 millimeters. It's not that one, that's your first choice. M22 by 1.5 is the second choice, and M22 by 1, jackpot, that's the one we've got, is your third choice. So that's the die that I have to buy to do that particular job and thread this part of the stem. So yeah, 22 by 1 millimeters, and that's the process I use to figure it out. And one other thing I'm going to do before I put this in the lathe to turn down this part of the stem is I'm just going to mark out 31 millimeters shorter. So at the moment the thread's about 34 and a half millimeters. if I add 31 to that, so 31, 34 plus 31, 65 give or take. So we're not splitting atoms here, so we don't have to get too precise. So 65 and a half or so, it doesn't really matter. So the thread's going to go down to the end of this depth gauge on my vernier, so about here. Now, marker's a couple of mil thick as well. So I've got to turn this down to 22. I'm going to go a couple of mil longer, just so that I've got a bit of clear space for the die to finish up. So I'm going to put a mark on the stem just here, and I'm going to use that as my guide, and we're basically going to turn down all of this to this point here, down to 22 millimeters to suit the threaded section. Okay, so we're over at the Hercus 9-inch lathe, and so we've got to mount this stem in the center, between centers on this lathe. So a 3-jaw chuck like this really isn't any good for this. We're going to have to put a center on either end and a face plate. So I'll get the lathe set up and show you how that's done. Alright, so I've got a face plate installed here now and a center, and I'll just install a threaded bit of rod here, a bolt instead of a hold down set, just to drive the triple around. So here's the go. So this end obviously spins. We're going to put that in here. That bolt's going to just basically drive the triple around like this. At the other end, I've got to bring in the end. I'm going to put a bit of oil on the dead center, because that doesn't spin, but the triple will be. So to prevent it from welding in, just use a little bit of oil. So tighten that in, lock that down, and once it's nice and tight, so that bolt, while the lathe's spinning, that bolt will drive the whole assembly around. And because we're between centers on the stem, everything's already concentric and set up ready to go. Okay, just for clarity, I'm going to extend this mark that we've made on the stem all the way around. So I'm just going to hold a Sharpie up against the shaft and then just drag that around there. Like I said, we're not splitting atoms, so we don't have to be within half a millimetre or anything like that. Safety glasses on. If you're using a lathe, you'll find chips going everywhere. You don't want any of that in your eye. So I've just spun this by hand to make sure there's clearance. Everything looks good. Everything's locked in tight. So we'll just start the lathe slowly. Yep, everything looks good. And what I start to do now is just take some fine cuts, and we'll get ourselves started. Okay, so we're back to the steering stem. I've finished turning it down to the same size as the threaded section, so it's 22 millimeters. It's just a shade under. So that's all done. The die has turned up, so it is the right size. So they did send the right one, which was great. So very carefully, you can see that this will thread on here. As such. So what we're going to do is continue the threading down past here and right to the bottom of this section here. So what I'm going to do is I'm going to wind it down a bit further before I put the handle on. I want to get that all the way on, so it's good to go. Use a tapping fluid or a cutting fluid. This one's called Rapid Tap. Yeah, it does a great job. So it's just a lubricant cutting fluid. So we'll put a bit of that on. I'm going to put the stem into the vise, and I've got some soft jaws here. These ones are magnetic, ones just plastic or something with a magnet on the back, so they'll stick in. You can use aluminium or even a block of wood, it works fine. obviously I don't really want to put hard steel onto the stem itself or onto the triple. You'll just damage the paintwork and dent it perhaps, so we'll avoid that if we can. So I'll just move the camera around a little bit. Okay, jaws back on. See if we can get this in some way that's useful. Probably not going to work, is it? So we'll have to do it this way. Just a note on this vise, so this is a very old Dawn vise. Dawn's an Australian made brand. You can still buy these vices, but they're pretty expensive because they are made in Australia, not China. But again, this is another eBay find, so you can buy these on eBay. And I just stripped it down and cleaned it up, cleaned all the grease and years of accumulated muck off it, and gave it a coat of paint, and happy days. It'll serve another 50 years. Okay, so you're not going to be able to see that on the camera, so we'll just pull this back a little bit further. Okay, so I'm just going to do this up firm so it doesn't move. I had to go and buy a die handle as well. This is an unusual size. It's a 45mm die, so not a common one at all. Okay, I'll line up a couple of these. Okay, so a bit of rapid tap. I'm pretty generous with that. It's going to go over 4, but I don't really care. Alright, so here we go. So the general idea will be to start cutting, and you're cutting a thread into the section of the stem, so you can feel it when it gets tight. That's where it's starting to cut. So we'll turn it around a little while, and then we back it off to break the chip. So half a turn or so, and then back. So a quarter of a turn really is about all I'm doing. And you can feel when you break the chip like that. Okay, and so forth. We're just going to keep doing this until we get to the end. So I might shut the camera down because this will take 5 minutes or so, and there's no point watching all that. We'll show you when we're finished. Okay, so we've finished threading all the way to the end of the stem. I've taken the handle off, obviously. The reason I'm leaving it like this is we're going to cut 31mm off, and we can do that in a whole bunch of different ways. I'm just going to use an angle grinder and cut it off because that's quick and easy. You could put it in a lathe and chuck it and then, part it off, but that's probably half an hour to set it up. So cut it off with an angle grinder and then clean up the end is a much quicker way of doing it. But when you do that, you're going to damage the first couple of threads with the angle grinder. So I'm going to leave the die on there, and then I'm going to spin it off and clean up the threads as I come backwards. So I'm going to leave it right down the bottom there, and just with a Sharpie and a steel ruler, I'm just going to hang the ruler over 31mm, just like that. And then put a mark on a couple of threads with the Sharpie. I'll go around a little bit so it's a bit obvious. Alright, so I'm going to get the angle grinder with a really thin blade and chop off the stem right there, back shortly. Okay, so we've just chopped off the 31mm off the end of the stem. You can see the grinder marks hopefully in the camera, and the dags left when I cut it. So now I'm just going to wind the die off and clean up the last couple of threads. Now these are precision tools. They're made very accurately, so I don't want to drop this thing on the ground and dent it or chip it. So when I get close to the end, I'm going to keep both hands on here right at the end. Last thread or so hanging off. There we go. Okay, so threads are all cleaned up. So now I'm just going to tidy this up on a belt sander. So we'll head over there and finish the job. Okay, belt sander, we're going to tidy up this end of the stem. And you can see on the piece I cut off, it's got a chamfer on the inside and a chamfer on the outside. So I'm just going to try and replicate that as best I can. Probably won't do too much on the inside. You need to either put a countersink or something in there, but on the outside I just want to put a chamfer on it just like this, just to make it easy to start the nut. So let's give that a go. Okay, so I've just taken put a slight chamfer on that. Really, it's taken off the edge and just cleaned it up. So I also, as you saw, I put it face first onto the belt. I just want to clean up some of the marks, sanding marks or the cutting marks on here. So now I'm just going to use a deburring tool, and I'm just going to clean up. There's a burr around the inside edge here, so I just take the deburring tool and stick it in there, and maybe see if I can get this on the camera. Run that around there. And cut the burr off, and hopefully you can see the shiny edge there where that burr's been cut off. So that looks a lot better now. And no sharp edges to cut yourself on, and a bit of chamfer here to start the nut on. So yeah, I'm pretty happy with that. And that's ready to go back to the customer. Thanks for watching.